4:30 a.m., our satellites detected a storm approaching the Ares 3 mission site on Mars. The storm had escalated to severe, and we had no choice but to abort the mission.
Okay. You watched The Martian once. And now you want to be an aerospace engineer. What is the first step you say? This is the start of your journey. For the rocket project we had to construct a rocket out of given materials that would launch an egg as high as possible and return the egg to safety. We also were given on-board tools to collect data from the rocket for later data analysis of the launch trajectory. Easy, right? Wrong. How do you design a rocket if you don't know anything about rockets? Without further ado, here is our design process. How do you make fins for a model rocket? I have no idea, but Google does. Watch how easy it is for me to Google how to make realistic sized fins. Too easy. We drew the fins in NX and cut them with the laser cutter. We used 4 small trapezoidal fins. Why 4 fins over 3 fins, you ask? 4 fins are easier to align correctly and 4 fins look way cool. Smaller fins have less drag. The fins are also airfoiled, which decreases drag even more. Less drag, more swag. Easy. Pro tip. If your fins aren't straight, don't expect your rocket to fly straight. The parachute is made out of a top-secret material I cannot tell you about legally. It is 12 inches in diameter. Smaller parachutes deploy easier. Talcum powder was also used to help the parachute deploy easier. Nothing mattered though because the parachute didn't deploy anyway. Pro tip. Cut a hole in your parachute if you want it to actually work. On top of that failure, the shock cord for the parachute was ripped from the body tube during ejection. Use copy paper, not notebook paper. Make your launch lugs small to reduce friction from the guide rod during launch. Of course ours were pretty much perfect. To reduce drag, and for simplicity, a hole was cut in the side of the rocket and the camera faced out of it. The moment you have all been waiting for. The launch.
5, 4, 3, 2, 1, 0.
They ask you how you are, you just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.
Before we launched the rocket, we collected data on the rocket motor. This is the graph. Different motors produce different graphs. This motor force peaked at 24 newtons. And the average force of this motor was around 10 newtons. The burn time was around 2 seconds. Remember this data for later. If you thought the first graph was dank, look at this one. This is a graph of the data collected from the rocket. The rocket reached its maximum height of 928 feet in 8.2 seconds. You can see this from the blue graph. From the red graph you can see the rocket accelerates to its top speed of 234 feet per second in 2.9 seconds, and it is pretty close to the rocket burn time. Notice how the rocket climbs to its max height quickly, and then descends at a constant rate of around 21 feet per second after the parachute deploys. What did we learn, you ask? Manufacturing quality is super important. Make sure your fins and launch lugs are straight. And make sure everything is attached securely. You don't want your rocket to blow up in flight. Eggs are strong. Our egg fell from nearly 1,000 feet with a partially deployed parachute, and the egg didn't break. And finally, making and launching rockets is fun. Super fun.